Hello, I'm Dennis Diefenbach. I'm from the QA company. I'm very happy to present this talk about the EU Knowledge Graph. And let's start. So the outline of the talk is the following. I'm first going to describe the infrastructure of the EU Knowledge Graph, which is Wikibase, and spend some few words about Wikibase. Then I'm going to describe the EU Knowledge Graph. So I think it's a good chance to look really into a knowledge graph. Generally, it's not so easy to do that. In part 3, I'm going to describe Cohesion, which is a concrete use case that is building on top of the EU Knowledge Graph, and some conclusion. So what is Wikibase? The Wikimedia Foundation hosts a lot of wikis. The most known is Wikipedia, but there is Wikivoyage, Wikimedia Commons for images, Wikispecies, and the one that we are interested in is, of course, Wikidata, because it's a knowledge graph. And this is the entry of the European Union. It's Q58 in Wikidata. And when people look at Wikidata, they generally think about the data itself. Oh, Wikidata is cool, there is a lot of data, but you generally do not think about the software that runs behind and that basically allows to construct this knowledge graph. And this software is Wikibase. It's open source software, as all softwares of the Wikimedia Foundation. And it is especially developed by a chapter of the Wikimedia Foundation, which is Wikimedia Deutschland. So the idea is the following. Wikidata is a great knowledge graph. It has thousands of edits every day. It has a lot of users. It is really a knowledge graph structure that apparently works because we constructed Wikidata with it. So why not to reuse the same knowledge graph infrastructure to construct another knowledge graph? And this is what we did with the EU Knowledge Graph. The EU Knowledge Graph is basically a knowledge graph constructed to collect information about the European Union, and we host it for the European Commission. In a few sentences, the EU Knowledge Graph is a data repository to store structured data about the European Union. And imagine, the European Union is a really big institution. There are millions of citizens living in this region. And if you think what you need to model about it, there are many, many things. There are countries, regions, people, projects, beneficiaries. And all of this we basically would like to potentially model into a knowledge graph. This is how the knowledge graph looks like. It's available under knowledgegraph.eu. And it looks like a typical MediaWiki installation, just that there is this Wikibase extension, which is the same software that runs behind Wikidata. So I already said that Wikidata is a very powerful knowledge graph. And so this could be a good reason to use basically Wikibase as an infrastructure, but there are a couple of other arguments that I would like to bring. So first of all, Wikibase is user-friendly. This is now the entity Q1 in the EU Knowledge Graph. It's the European Union. I mean, it's a graph about the European Union, so Q1 should be the European Union. And if you think of it, if you think about Wikidata, Wikidata is edited by tens of thousands of users, and they are not expert users. They do not know anything about RDF. They do not know anything about Sparkle, but still they are able to construct together a huge graph. And this is thanks to the fact that also the software is basically a very easy interface where people can understand the data and edit the data. Another argument, which is very important for this conference, is that it has a graph structure. So this here is the European Union in the EU Knowledge Graph. And for example, we have this edge that the public holiday is the Europe Day. Not sure if you knew. We could go to this graph, to this edge, explore it more. It commemorates the Schuman Declaration. We have information about the Schuman Declaration. So it has a typical graph structure. Also, it can be queried. So the query service, in fact, is a very essential part of the Wikibase ecosystem. So if you install Wikibase, you do not get only this interface to basically edit the data, to visualize the data, but you get also this query interface out of the box, which is used by, it's crazy, they are against this endpoint every day. There are thousands of 10,000s of queries that are run against the official Wikidata Sparkle endpoint, and you get basically one for your organization. So here, for example, we are querying all countries in the European Union with their population, sorted by population. There are also these nice charts that are coming out of the box, which allow you basically to render the information. Another argument is that this graph is edited both by humans and by bots. So basically, either you go directly to the page, you basically edit the entity, or you write a bot that is running over a large part of the data and that is carrying out specific tasks. And in Wikidata, there are thousands of bots running over the whole data. And also in the EU knowledge graph, we have a couple of bots that are making very specific actions on top of the data. It scales well. Wikibase hosts Wikidata. Wikidata contains 17 billion triples. If you would like to reach the scale into an organization, it's not something that is so trivial. And also the EU knowledge graph is meanwhile a pretty large graph. It contains nearly 1 billion triple. So it's not something small. It is multilingual. That's in this context particularly important because we have 27 member states, we have 24 official languages. Potentially there are people from different languages collaborating on the same knowledge in different languages, and this is what a knowledge graph technology allows, and also Wikidata allows. For example, here we see how the European Union is contained in many different languages. Something that is rather rare for a knowledge graph infrastructure is that you have full track of changes. So this here is now a particular entry in the EU knowledge graph, and if you go to the history, you see how it evolved over time. So on the 11th January 2020, DG Regio created this item, and then you have different users that edited and that added different information. And you see really, so this data is not static. Over time, we add metadata, we edit information. There are bots that edit parts of the information. So it's really something dynamic. Okay, so I showed you why we use Wikibase. And now let me give you some impression of the content of the EU knowledge graph. So basically we have information about European institutions. This here is Q171 Eurostat. We have quite a bit of information about Eurostat. Some of them are coming also from Wikidata. We have information about European countries. I mean, how to describe the European Union without European countries. We have information about capital cities, about head of states, like for example here Emmanuel Macron. And we have also information about the ministries that are in the European Commission. So this is an article about the Directorate General for Regional and Urban Policy, DG Regio, which is part of this project. And there are information about it. We have information about buildings. This is a canteen in Berlaymont. I'm not sure if you look at the news sometimes. It is located in the Berlaymont building, and the Berlaymont building is basically this thing that you might have seen sometimes in the news. So we describe basically a particular canteen in this building. It contains 1.8 million projects which are co-funded by the European Union around Europe. I'm going to describe this a bit more in detail afterwards when we go to the use case. It contains 640,000 beneficiaries of basically institution or private person that received funds by the European Union. It contains NUTS, so we describe all statistical or geographical regions in Europe. This is important because it's a very important knowledge asset for the European Union in the graph. And in this case, it's an article about the province of Asti, which is a particular region in Italy, in the Piedmont area. it is also used for other use cases. So here it is a catalog of linked data solutions. So at some point, someone wanted to put up a catalog of what are linked data solutions that exist, also to make aware of linked data solution inside the Commission. And so if you have a linked data solution and you would like to increase its awareness inside the European Commission, you can basically add your linked data solution to this graph and be part of the catalog. And something that was recent is there is a catalog of Sparkle endpoint. So there was the wish to basically have what are all Sparkle endpoints that are there in the LOD cloud. And so there is a big catalog with more than 200 Sparkle endpoints with their address and the number of triples and some metadata if available. And of course, there is more. So you really see it's a knowledge graph, which is describing a large number of heterogeneous entities. And they are organized together in a graph smoothly, like you would have it in Wikidata. Okay, so I would like to spend a few words about how we import data into this graph. We start with any piece of structured data. In this case, it's a piece of a JSON object, and it's describing a building, an office, Beaulieu 25 Croissant. It was the article that we were seeing before. The occupant is Climber. We don't know exactly what Climber is. There is some address and some more information. So basically what we do is that first we want to establish a data model for it. So we need entities, in this case, like building, offices. We need properties like address, opening hours, occupant. And what we do is that we do not reinvent all these concepts from scratch, but whenever they exist, we take them from Wikidata and we import them locally into the graph. So, for example, this concept of office, Q244596, is not something that we created, but we cloned it on Wikidata locally. And what we get is how office is called in many languages, that it is a subclass of room, of workplace, of facility. We get how it is pronounced, we get an image for it. So it is really cool because basically our local knowledge graph is reusing public knowledge and we do not have to reinvent concepts. The same we do for properties. In this case, we reuse the property occupant. In this case, it's P6441. In Wikidata, it's P466. And we get, for example, property constraint. What should be the domain of this property? What should be the range of this property? And again, we didn't model this data. We got it for free. The community is providing it for us. So what we always do is that we keep identifiers between the original data source and the data source and the knowledge graph so that there is a connection and so that if the data changes over time, we can basically keep track of it. And at the end, the import itself is done either via client libraries. There are client libraries for every programming language. We use a lot Python. We also use OpenRefine. And there are different alternatives. The community is very big, and they thought about many different types of, many different ways of ingesting entities. And at the end, we have this. Instead of this JSON object, we have this entity with a clear identifier where people can go, explore it, understand this data. It's an instance of building, of office. Here we reuse these Wikidata entities. It's owned by the European Commission. There is an image. It has some opening days, and the occupant is not this Climber, which didn't mean anything, but it's the Directorate General for Climate Action, which is one of the DGs that we had already in the graph. So everything is integrated and well aligned. Okay, so I showed you the knowledge graph. I showed you the infrastructure, what more or less it contains. But I mean, we want the knowledge graph to do something with it. And I'm going to present one of the main use cases, which is cohesion. And for that, we need to do some European politics. So the European Union is spending a lot of money to basically increase the growth in underdeveloped areas of the European Union. The European Union is big. There are areas which are more advanced economically and some less. And basically 30% of the budget of the European Union, which in the programming period 2014-2020 was 350 billion euros, is spent basically to increase growth in underrepresented or underdeveloped areas of the EU. And it works more or less like this. So there are people sitting together in Brussels and say, we would like to increase climate change. We would like to do something about climate change. We would like to push for innovation. And we would like to combat unemployment. Then are saying, for this area, we allocate this part of budget. For this area, another part of the budget. Then they are going to the member states and they are saying, you have to implement projects in this specific area with this budget. The countries are then implementing projects locally and are basically making calls, and people can apply and say, I will make a great project for climate, I will make a great project where I create unemployment. And then there is a selection process, these projects are carried out, and then at the end, the member states have basically to report, we did all this project in this area with this budget, and etc. And the goal of Cohesion is basically to aggregate all this information across the 27 member states and to basically make this data uniform, accessible to citizens, but also accessible to policymakers. So at the end, the data that we need for making all of this is all the data that is published by the different member states. In fact, it is published by different territories in the different member states. Then we need a lot of files that describe this cohesion policy. What is a category of intervention? What is the thematic objective? What is the policy objective? How these vocabularies are related to each other. We need data about geographical entities because we want to describe basically where these projects take place. And we also integrate data about Wikidata to say, oh, this is a beneficiary. This beneficiary exists in Wikidata, and we can basically extract metadata about it to enrich our graph. This is a typical project. It's a project in France. We have its name in the 24 official languages. It is contained in a specific region. It's an instance of a Cohesion project financed by the EU in France for €500,000. The total budget was 1.3 million euros. It started and ended at a certain time. There is an intervention fee, a program, a fund, and some other metadata about it. We do not only import this data, but we also enrich it. We translate everything. We compute geo-coordinates if only the addresses are given or only the postal code are given. We deduce the region in which this project is, and we link all of this in Wikidata to enrich our knowledge. For example, in this case, originally in the data we had just this as information about the beneficiary, but we linked it, and now we know that this beneficiary is located in this street. It has this number of employees. It was created at a certain date and time, and more. On top of this, there is a website constructed which is called Cohesion. It's available under cohesion.europa.eu, and it looks like this. Basically, this is meant as a tool for European citizens to discover how the money is spent. The money of the European Union is spent in Europe. We can go, for example, to Poland, to a certain sub-region. We have where this project are carried out. When we click on a project, we see the project itself, all its metadata, and this is connected with the graph. So this is the original entity in the graph. And this here is the corresponding visualization that we put on top. And in fact, every interaction that you make on this website is a Sparkle query. So this is a GeoSparkle query. This is a GeoSparkle query. This is a GeoSparkle query. This is a select query that is running over the graph. In this case, we do not have a translation available. And also you can search over the project. by country, by region, by all the different facets. And you have also beneficiaries aggregated over all the 24 member states. So now we know that the top beneficiary in the European Union is the General Directorate for National Roads and Highways, which is some institution in Poland, and which received 8 billion euros from the EU that was spent across 71 projects. Also, maybe here, just to make clear this link of Wikidata. So before, in the original data, we just knew that the beneficiary is this, but in fact, the description is coming from Wikipedia, the image is coming from Wikidata. So basically, by enriching the data, the private data that we have with public data, we can create a better service and understand better the data. This here is the tweet about the launch of Cohesion. It was launched more or less 1 year ago. We were all sitting in the Berlimont building. There was the Ministry for DG Regio that was presenting it, and we were hoping that the website would not collapse. And since then, we are in production, and it's a pretty successful project inside of the Commission. To conclude, I have shown you how Wikibase is used as an underlying infrastructure for the EU knowledge graph and why it is a good infrastructure in general for knowledge graphs. I've shown the content of the EU knowledge graph, how we ingest the data, how we maintain it fresh, which are the services that are offered around, and I have shown a concrete use case that we have basically constructed on top of the knowledge graph and which is in production today. I would like to thank the Doris team at DG Connect, the knowledge management team at DG Regio, and Wikimedia Deutschland. People from all of this institution helped to make this project successful and working. And that's it. Thank you very much for your attention, and I'm happy to answer questions.
You gave an example of the term office, which comes from Wikidata. I'm just curious why you chose to copy that into your graph instead of, linking to Wikidata.
In fact, there are two scenarios which are possible, of copying and linking. We do not do linking because it's more difficult more from a software point of view, so copying is easier. But in fact, both scenarios are realistic. For example, for beneficiaries, we really want to copy the data because we want to say that this thing is a beneficiary. And this is not the thing that we want to put in Wikidata, because in Wikidata people would think, why is this a beneficiary? What does it mean? So basically, in some situation, you would like to couple external knowledge with internal knowledge, and then you really need to make a copy. And in semantic web, we do something very similar. So either we import a vocabulary, or we say we extend it by using RDF subproperty off, and then we basically add additional data.
Hi, my question is, when you are doing data ingestion, where do you check for, or where do you verify the data or check for consistency? Is it a pre-ingestion process or post-ingestion process in terms of the knowledge graph? And then my second question is that when you are doing all that ingestion, I don't know if it is pre or pro, but when there is a user who is doing the dynamic change, at that time, how do we verify and make the check that the data is consistent?
Okay, so maybe for the first question, so generally we try to make the data consistent at the beginning. So for example, when we import beneficiaries, we try to link it to existing beneficiaries. But it might not always work. So we have also post processes that basically take all the beneficiaries that we already have in the graph, try to find similarities, and these entities are then merged afterwards. So both things happen just because you never can do it perfect if you have a lot of data. The second one is, in fact, the people that are touching the certain part of the graph generally know what they are doing. So we do not get many problems about data consistency. And you saw that we constructed this website on top. In fact, the application layer generally tells us if there is something wrong. Because if you see something wrong in the application, you know that there is something wrong in the data. So in this case, the application is a very good test if you model the data correctly. But in general, yeah, we do not have such big problems about data quality in this direction. Okay, then thank you very much. Enjoy the conference and see you around.